All right, lesson 6. This is our last lesson of the unit. So if you're watching this, you should be following along, taking notes on pages 24 and 25 of your workbook. Today we're gonna write, solve, and graph compound inequalities. Maybe if you don't remember what a compound inequality is, you can look at the word wall, or you can look back in our lesson 1 vocab slides. But in general, a compound inequality, so our first example 1, says understanding compound inequalities. That is when I have 2 or more inequalities and they're joined either by the word and or the word or. So we're going to look at both of those today. So first we're going to start with some and examples. In your workbook, this is on page 24. I wrote that down at the bottom. 24. There's also some notes for you to be writing in your blue section of your workbook. So what's the difference between an open circle when I'm graphing an inequality and a closed circle? An open circle is for when I have less than or greater than. And then a closed circle is when I have less than or equal to or greater than or equal to. So here's the difference between when I just have x is less than 2 and when x is less than or equal to 2. So when 2 is included, we close that circle. And then you have that line under the less than sign. And that's when it looked like what it would look like when we graphed one inequality. And so now we're going to graph 2 inequalities at the same time. So if you see the difference, like looking at example A, I don't have an arrow going to one side. I have a shaded part in between 2 points, right? So what do I see? The shaded part is what x is equal to. So I see that x is greater than -2, not equal to because it's an open circle, right? So because it's shaded to the right of -2, I see that x has to be greater than -2. But I also see that and x also has to be less than or equal to +6. Why? Because I see a closed circle at 6 and it's shaded to the left, all the numbers smaller. So x also has to be less than or equal to +6. I could put those together also to write it as one statement, which I kind of like this better, with x in the middle, right? X has to be less than or equal to +6, but x is greater than -2. And I like to write it that way because I feel like it looks just how the graph looks, right? X is in the middle, and I have -2 on one side and 6 on the other. And when I write it in a statement like that, it looks like the graph, right? So maybe pause the video and try B for yourself, and then play the video and see if you're right about B. So I do see that for B, x again has to be greater than -1, not equal to because it's an open circle, and also x has to be less than or equal to, I don't know what that number is. If I keep continuing on my number line using one digit, it looks like it would be 3. 3. So again, if I wanted to put that together into one statement, x would be less than or equal to 3 and x would be greater than -1. And again, I like that because it looks just like my graph. So we're going to also look at example 2 in your workbook, and this is going to be an example of an OR inequality, a compound inequality. And so we're actually going to solve it first, and then we'll do our solutions on a number line. So I already drew my number line down at the bottom so that I'm ready for when that happens. And I put a note for you for your blue space. Remember, if I multiply or divide by a negative, I have to flip the sign. That's from lesson 5. So it's very easy to solve compound inequalities if you can already solve single inequalities. I'm really just going to solve them both. So I'm going to write them both out, everything that I have in my problem, and I'm just going to solve them each individually, and then I'm going to put the solutions together. So it's really no different than lesson 5. I'm just adding these words in here. And so I'm going to try to get x by itself. First, I'm going to subtract 2 from both sides. That cancels out. I have -3x is greater than -7 minus 2 is -9. I already know I'm going to divide by a negative. As soon as I saw that -3, I was like, don't forget, right? So I divided by -3 to get x by itself to cancel out that times -3. So my sign is going to switch from being x is greater than 2, x is less than. And a negative divided by a negative is a positive. 9 divided by 3 is 3. So I switched my sign. Remember that, right? So it was greater than, now it's less than. And on the right side, I have parentheses, so maybe I'll distribute 2 times x and 2 times negative 2, right, is 2x minus 4 is greater than or equal to 6. Now I'm going to get x by itself. I'm going to add 4 to get rid of that minus 4 to both sides. Now I have 2x greater than or equal to 6 plus 4 is 10. Divide both sides by 2 to get rid of that 2 times x. I have x is greater than or equal to 5. Double check that I didn't divide by a negative. I did not. So my word in the middle is still or. So now we're going to see the difference of what it looks like when it's an or inequality, a compound inequality, right? So how am I going to graph this? Well, I know that x is less than 3. So I'm going to label my number line. Maybe I'll put 3 somewhere in the middle. And then my other solution is that x is also going to be greater than or equal to 5. So I'll make sure that 3 and 5 are both on this number line. Maybe by putting 3 and 5 in the middle. And then I'm going to do an open circle at 3 because it's x is less than 3, not equal to, but a closed circle at 5 because it's greater than or equal to. And I'm going to shade as it tells me. So x is greater than or equal to 5, so I'm going to shade all the numbers greater than 5. And then x is less than 3, so all the numbers less than 3. So see how that looks very different than the graphs in the last question, right? So my final answer, I solved my inequality. My final answer would really be this whole thing. X is less than 3 or x is greater than or equal to 5, and I graphed my solution. So again, pause if you need more time to write, but number 3, I put in the notes, what does it look like when I have an and compound inequality, and what does it look like when I have an or compound inequality? So pretty much anytime you solve a compound inequality, my ands, I should shade the region between the circles, and or inequalities, usually I'm shading the region outside of the circles. So let's put that to the test. We solved one that was or, now we're going to solve one that's and then we will have done all the different types of situations. So they wrote this inequality as one statement, kind of like we did with example 1. So to solve it though, I do want to break it back up, right? So I have 2x is less than 4x minus 5, and I know that 4x minus 5 is less than 15. So the reverse order of what we did with question 1, it's kind of like I'm taking the first part of my inequality and writing it, and then I'm taking the second part of my inequality and writing it separately so that I can solve each of them. And then I'm just going to solve. I'm going to do my line down the middle. I'm going to try to get x by itself. So for this first one, maybe every time I see like a plus or minus a number, I got to do it first, although I'm not adding that to anything on the other side. I cannot add 2x and 5. They're not like terms, right? They're like apples and oranges. I cannot add those together. They're not both x's. But now I have 2x plus 5 is less than 4x. I can get rid of one of these groups of x's, maybe the 2x. I always like to try for the smaller one, but it doesn't always work out like that. Sometimes you have to have a negative number. So 4x minus 2x is 2x. And so my final step is to divide both sides by 2. Divide by 2. 5 divided by 2, I could write it like that. I could write 2.5, right? Or 2.5 less than x, right? Those 2's cancel out. So x is greater than 2.5, or 2.5 is less than x. Those two things mean the same thing. And, right, I still have an and statement. On the other side, what do I have? Let's get rid of another minus 5. Add it to both sides to cancel out that minus 5. I have 4x is less than 20. And then divide both sides by 4 to get rid of the 4 times x, and I have x is less than 5. I'm going to double check really quick that I didn't divide by a negative or multiply by a negative. I did not. So I think my answer is complete. And so I could write my final answer back as one statement again, right? X is in the middle. X is less than 5 and greater than 2.5. So if I wanted to write my final answer like this, I could. That might help you graph, right? So 2.5 and 5. So maybe I'll start my number line somewhere with 2, 3, 4, 5, 6. That looks good. If it wasn't good, I would probably erase it and start over. And so open circles, both are open circles because they're not or equal to. So I have 2.5, that's halfway between 2 and 3, and I have 5. So X is in between those two. So I'm shading the region in between. Again, looking back at the notes we took on this page, you see what an and inequality graph should look like versus an or compound inequality graph, right? Okay, so make sure you take the time. That was a lot of notes for those 3 problems. We are also going to set up the inequality for example 4 in your workbook. I think this question is really weird. I was going to skip it, but good practice also to practice the weird ones. So it says Enrique's dog River consumes between 510 and 540 calories. So I'm assuming that's where my inequality is going to start, right? We're in between 510 and 540. I might be wrong, but we'll see. I always do that. I kind of map out in my mind what it might look like. She's been eating 1.5 servings daily of food that is 320 calories per serving and treats that have 15 calories. This is what's weird. Now they just without even doing that, using that information, now they say, suppose River now has new treats. Now the treats are 10 calories each. How many of the new treats can she have to remain in her calorie range? So I am assuming this 15 calorie treat is just not even relevant anymore, even though we didn't even use it, because now it's saying that she's eating new treats. So weird that they gave us information that's not useful. Also, how many calories is she eating a day? She's not eating 320 calories a day because she's eating 1.5 of servings of that. So to find out, I have to multiply 1.5 by 320, which I put in my calculator is 480. So really she's eating 480 calories plus she's eating the treats. So 10 calories for every treat. Since that is my question, right? My question is how many of the new treats can she have, right? So that's whatever I'm looking for. What I don't know should be X. X should be the number of new treats she eats, right? So I think X is going to be multiplied by 10 because it's 10 calories for every new treat. So 10 times X. If she eats 1 treat, it's 10 calories. If she eats 2 treats, it's 20 calories. And that all needs to be less than, I'm assuming, or equal to 540, but it has to be greater than or equal to 510. I don't know if it could, that's another weird thing about this problem. I don't know if it could be equal to 520, but it says between 510 or 510, but I don't know because it says it has to be between 510 and 540. I'm assuming it could also be equal to 510 or 540. So if I want to solve this compound inequality, I'm going to break it again into 2 separate inequalities. 510 is less than or equal to 480 plus 10x, and then also 480 plus 10x has to also be less than or equal to 540. So kind of a lot going on here. That one was a tough one to set up, but you try to solve it and then maybe double bonus points if you also graph it. And if you want to take a look at this, pause your video. This is just another illustration of the difference between the or compound inequalities and the and compound inequalities. Oh, time for class.